Alright, and welcome to 2-1, X's all around. Now, let's go ahead and take a look at example 1 because this is what we call a special case. And you're going to notice that we have X's on both sides. So we're asking our second question, are my variables together? And the answer is no. Now typically we're going to move the smaller x, but in this case you'll notice 5x is the same as 5x. So it really doesn't matter which one you move. Now since it's positive, we will subtract 5x from both sides, subtract 5x, and wait a second, that zeroes out, and we get 8 equals, and 5x minus 5x also zeroes out, and we're left over with that negative 9, and we get 8 equals negative 9. Now, whenever your x's or your variable disappears completely, you either have infinite solutions or no solutions. So we want to ask ourselves, is this a true or false statement? Does 8 equal negative 9? And since that is a false statement, we would say that there are no solutions. And that is our final answer. Now let's go ahead and look at example 2. Now for example 2, we go to our first question, can I simplify the left or right? And so on the right side, we can simplify by distributing. So we'll write this. We'll say, okay, well, we got 6x minus 10 equals 2 times 3x, which is 6x, and 2 times negative 5, which is negative 10. Now we go to our second question. Are my variables, are there variables on both sides? And the answer is yes. And so, well, once again, 6x and 6x, they're the same. It doesn't matter which one we move. And so we're going to subtract 6x from both sides. Now wait a second, that zeroes out, and we're left with this statement right here, negative 10 equals negative 10. And is that a true or false statement? Does negative 10 equal negative 10? And since that's true, we would say this, we have infinite solutions. Alright, well, with that being said, let's just circle infinite solutions, that's our answer. With that being said, please pause the video, finish taking any notes that you have or need to, and let's move on to our third and fourth example. By the way, if you're going to stop right here, you're going to fail this section hard because I have yet to introduce solving with fractions. So please sit through these next two examples. Okay, here we have example 3, and now we're going to start solving with fractions. We have 3/4 x plus 10 equals 5/8 x plus 26. So both sides are simplified, and we ask ourselves our second question. Are my x's together? And the answer is no, they're not. So let's go ahead and try and move our smaller x. Now it's my guess that 5/8 is smaller than 3/4. I know that 3/4 is like 75 cents, it's 0.75. So we're going to subtract 5/8 minus x minus 5/8 x, and you'll notice something here. There's a zero pair, but on this left hand side we actually wind up with 3/4 minus 5/8. Now what I'm doing right here is super important. Whenever you're doing fraction work, you need to do that fraction work off to the left or the right. It doesn't matter, but you have to do it to the side so you keep your work nice and clean. Now from here we see, this denominator is 4 and this denominator is 8. We have a problem. We don't have a common denominator. So the question becomes, can I multiply 4 by any number to make it become 8? And of course we can. We can multiply 4 by 2, and if we multiply the bottom by 2, we have to multiply the top by 2. So we know that 3 times 2, top times top, will give us 6 over 4 times 2, bottom times bottom, 8 minus 5/8. And of course, now we have common denominators, we can just subtract on the top. We know that 6 minus 5 will give us 1 over 8x plus 10 is equal to 26. Now from here, we know we want to get the x by itself, so we get rid of our addition, so minus 10 minus 10. And now we have 1 over 8x is equal to 16. Now if you'll recall back to our very first lesson solving review, we know that in order to get rid of a fraction, we don't want to divide, we want to multiply by the reciprocal. And remember, the reciprocal means to flip. So 1 over 8, we multiply by 8 over 1. And those go away. Now remember, what we do to the left, we have to do to the right. And 8 over 1 is literally just 8. So what are we saying? We're saying our answer is going to be x equals 16 times 8, which no math teacher should be 128. Let me just double check that with my calculator. Double checking with my calculator, 16 times 8. Yeah, 128. Perfect. And there's our answer. Let's move on to our fourth and final example. And guys, you have got to watch this example or you will miss these. Alright, here we are in example 4, our fourth and final and most important example. Now let's run through our questions. Question number 1, can I simplify the left or the right? Well, we can't simplify the left side any further. It's just 3 over 2x plus 12. But on the right side, we can simplify by distributing. So we'll put this as 2 over 1. We know that top times top, 2 times negative 4, will be negative 8 over, and on the bottom, 1 times 5 is 5. So that gives us negative 8/5 x. And we also have 2 times positive 8, which would be 16. Now from here, we go to our second question. Are my variables together? And they're not, so we'll move the smaller one. If this one is positive and this one is negative, well, of course, we're going to move the negative. So we will add 8 over 5x. We'll add 8 over 5x. And then from there, we know that we actually have to do a little fraction addition. So let me come over here to the right side this time, and I'll even use a different color. We have 3 over 2 plus 8 over 5. And notice, since they're both x's, I'm just going to leave that off to make this a little bit simpler. Now from here, the question becomes, 2 and 5 can both go into what number? Well, they can both go into 10. So 2 times what number gets me to 10? Well, in this case, it's still going to be 5. And if I multiply the bottom by 5, I have to multiply the top by 5. Now what about over here? We know 2 and 5 can both go into 10, and so we ask ourselves, 5 times what number will give me to 10? Well, that would be 5 times 2. And what we do on the bottom, of course, we do on the top. Okay, so let's go ahead and multiply these guys out. We know that 5 times 3, top times top, is 15 over 5 times 2. Bottom times bottom is 10. And here we have 8 times 2 on top, 16 over on the bottom, 5 times 2, which is 10. Now that we have a common denominator, we can add the tops, 15 plus 16, which will give us 31 over 10. And so now I can take that and know that 3 over 2x plus 8 over 5x is 31 over 10x. And of course I have the rest of this, plus 12 equals, here's my 0 pair, 16. Now from here, how do we get rid of the plus 12? Well, minus 12 on both sides, and that goes away. And now we have 31 over 10x is equal to 16 minus 12, which is 4. Now once again, back to example 3. To get rid of a fraction coefficient, we multiply by the reciprocal, which means we flip it, and of course 31 over 10 flipped becomes 10 over 31. What we do to the left, we do to the right. We multiply by 10 over 31. And that goes away. And I'll actually bring this all the way over here. And we could say this. X equals, well, this is really 4 over 1. So 4 times 10 on top is going to be 40 over 1 times 31, 31. And we have our answer. X equals 40 over 31. Good luck, and I hope these help you out. I'll see y'all in our next video.